Welcome to the Georgia Highlands College Math 97 and Math 99 instructional videos. In this video segment, we will look at some examples from the last video segment with the question, how can I choose the correct factoring method? So let me just quickly recap what that process was of choosing. You always want to check for a GCF first. Then you move into counting the terms. And you'll either establish that it's a binomial, a trinomial, or a 4 or more termed polynomial. And there are different methods for each of those. And then you'll apply the factoring method. Make sure that when you get done factoring, you'll check each of the factors to see if they can be factored further. Do so if needed, and then finally check with multiplication. So in this video, we're going to run 2 examples through this process to show you how we determine the correct method of factoring. Let's take a look. Let's take a look at a couple of examples and run them through this process of figuring out what method to use to factor each of these. So we'll start with the example on the left-hand side of the screen, 5x to the 4th minus 45x squared. Now remember, with our process, no matter which factoring method you end up using, you always want to check for a GCF first. And you may notice that this binomial does have a GCF of 5x squared. So if I begin by factoring out the GCF of 5x squared, I get 5x to the 4th divided by 5x squared leaves us with x squared, and negative 45x squared divided by 5x squared leaves negative 9. Now we have our GCF taken out, so looking inside the parentheses, we'll move to the next step of the process, and that's to determine what type of polynomial it is by means of how many terms it has. Notice we have 2 terms inside the parentheses, x squared and negative 9, which makes this a binomial. So we have one of 3 processes that would work for us with factoring, if it can be factored further, and that is difference of squares, sum of cubes, and difference of cubes. And hopefully it's jumping out at you that what's inside the parentheses is a difference of squares, but we need to check. And to check, we just want to see if we can fit that into the mold of something squared minus something squared. And we see that we can square x to get x squared, and we can square 3 to make 9. So what's inside the parentheses does fit into our difference of squares model. And when we write our final factored form, don't forget you want to bring down your GCF to become part of your final factored answer. And then to factor our difference of squares, x squared minus 9, it fits into a plus b times a minus b, which would be x plus 3 times x minus 3. And it appears we have this completely factored, but we just want to double check and look back through each of our factors. So we have 5 and x squared, which cannot be factored further. X plus 3 has no GCF in both terms. And x minus 3 does not have a GCF for both terms either. So it appears we have it in our final form here, but we just want to check and make sure. So multiplying it back out, 5x squared times x plus 3 times x minus 3. First, we distribute that 5x squared into the first set of parentheses and get 5x cubed plus 15x squared. And then we multiply that result with the x minus 3 through distribution of each term in the first binomial with each term in the last binomial. And when I multiply 5x cubed with x, I get 5x to the 4th 5x cubed times negative 3 is negative 15x cubed. Coming back and distributing the 15x squared, I get 15x squared times x is positive 15x cubed. And 15x squared times negative 3 is negative 45x squared. Combining your like terms, we find that we have a pair of opposite terms, negative 15x cubed and positive 15x cubed combined to make 0, which leaves us with 5x to the fourth minus 45x squared. Since we ended up with the same polynomial we began with, we verify that 5x squared times x plus 3 times x minus 3 is the factored form of our binomial 5x to the fourth minus 45x squared. Now let's move on to the example on the right-hand side of the screen. I start with 4x squared minus 16x minus 48. First step is to check and see if we have a greatest common factor. And we do. We see that a factor of 4 lies in each of those terms. And when I divide that GCF out of all three terms, I'm left with x squared minus 4x minus 12. Well, we're not quite done yet because we need to check and make sure that we can't factor what's inside the parentheses any further. So since I have 1 as my leading coefficient, I will use the factoring method of figuring out which factors multiply to make negative 12, but add to make negative 4. And if I can come up with those factors, I can factor the trinomial inside the parentheses further. And we see that the factors negative 6 and 2 multiply back up to make negative 12, but combine to make b, which is negative 4. So, to write out our final factored form, don't forget, bring that GCF down to become part of your final answer. And then the trinomial in the parentheses factors as x minus 6 times x plus 2. And just to remind you, the minus 6 came from this factor negative 6, and the x plus 2 came from the positive 2 there that we found. So we have the final factored form of that trinomial, and we'll just check it real quick to make sure that we have done this correctly. So we'll start by distributing the 4 into the first set of parentheses. And when we do so, we get 4x minus 24. And we're going to multiply that by x plus 2. So we distribute each term in the first binomial to each term in the second binomial. 4x times x gives 4x squared. 4x times 2 is positive 8x. Coming back and distributing the negative 24, we get negative 24 times x is negative 24x, and negative 24 times 2 is negative 48. Combining our center-like terms, we end up with 4x squared minus 16x minus 48, which verifies that we end up with the same trinomial that we started out with, telling us that 4 times x minus 6 times x plus 2 is the final factored form of the trinomial 4x squared minus 16x minus 48. So I hope that this has been helpful for you to see the process of walking through each of the steps to determine how to best factor your polynomial that you've been given. Now, by no means is this an exhausted list of all of the methods of factoring. You can certainly go back and watch any of the factoring videos if you're fuzzy about any of the methods, but this just gives you a process to begin eliminating factoring methods that won't work for your particular polynomial. So if you have any other questions about how to decide which method to use when factoring, make sure you contact your Highlands instructor. Thank you.